This video will demonstrate a way to bring 3D stereo images into Unity for uploading into VRChat. The tutorial assumes that a project has already been created in VRChat Creator Companion. And so now I will show a project, and I'm going to show the ground and the collider. This is my test project world. I've created it in VRChat Creator Companion. I called it Test Project 01. I renamed the scene. I imported brought in the VRC world object, which is necessary. Turned off the main camera because it's not necessary. The directional light is on, and I created a ground plane, put in a quad and renamed it to ground. It's a ground. And then I added a shader so that it would have some color. Now you can see the ground plane is here. It's actually just a little bit below 0, so that when you spawn in, you don't fall through it into space. Now I'm going into the Assets folder in the project, and I'm going to bring in the Stereoscopic shader from my file manager. So this is the Assets folder, the Assets panel, and I have the shader, the Stereoscopic shader, in a directory where I keep utilities. So I have utilities, shaders, and here's where I keep shaders. So I can just drag this file over and drop it into the Assets panel, and it's ready for use. Now I'm going to create a folder specifically for images in the Assets folder in the project. So in the project, I can right-click on the Assets folder in the project window and say Create Folder, and now I can give it a name. I'll call it Images. Now I'm going to save an image into that folder as a JPEG. The image may already be on your hard drive, or maybe you just downloaded it or copied it from the internet. In any case, I'm going to place that image in the Images folder. And again, your image may be on your drive, in which case you can just drag it from the file manager into the Assets folder. But in this case, I'm going to save this image. This is a side-by-side, parallel side-by-side image. I'm going to save it. And I'm going to save it into the project folder under Assets, and in the Images folder that I just created. I'm naming this image Example 1, and I want to make sure that it's in JPEG format. Then go back to the project, open the Images folder, and you see that image is there. If I click it, I can see in the inspector, I can see properties of that image. We don't need to change anything at this time. Now I'm going to create a material, rename the material, select the Stereoscopic shader, and then drag the image into the shader. So in my project, there are various ways to do this. What I do is right-click in the panel, in the Assets panel for images. I go to Create, Material. So now I have a material, and while it's fresh here, I'll give it a new name. In this case, I'll name it the same as the image. I think that's a good policy. So the image and the material have the same name. And notice that the shader, default shader, is standard. So I click on that, and now I see that there's a shader type called Dargo Shaders. Dargo is the person who created the shader. Inside that folder is the stereoscopic shader. So I select that. Notice that the shader parameters have changed. And now I grab the file, the stereoscopic file, and drag it and drop it into this little window. Notice that the material now has that stereoscopic picture mapped onto it. Now there are various ways to bring an image into the scene, and I'm going to show you the way I prefer. And so in the hierarchy, I'm going to create an empty container object. And I'll talk about why later. And then I'm going to rename that and set it at the 000 point as a good starting point for reference. So I start by right-clicking in the hierarchy panel. I say create empty, and it brings in what's called a game object. I'm going to change the name of that to example image container. There's nothing special or magical about that name. It's just that I'm using it as a descriptive term. All right. Now that container object is in the scene, and it's close to the origin, but I'm going to make this 000 over here, so that the container, which is actually not visible, is at the origin. Next, I'm going to create an object inside the container, a child of the container. I'll use a quad object, and then we're going to take a look at it and drag the material onto the quad so you can actually see the material applied to the object. So now I'm going to right-click on the container object, a 3D object. I'm going to create a 3D object using a quad. And at this time I'll change the name of that to example 01. So again, I'm staying consistent by naming the quad and the image and material all the same, so that they're easy to keep track of. Now in the scene, I'm going to zoom around. So I'm looking at the front face of that quad, and right now half of it is down in the floor. It's hidden. So I'm going to move the quad container, the image container, not the image object itself, but the container, up out of the floor. So now we're seeing the entire surface. And then I'm going to drag the material that we created. I have a couple choices. I can drag it onto the quad in the scene, or I can bring it over here into the hierarchy and drop it here. In either case, they're basically the same. So I'll take a closer look at that. So this is phase one of bringing the 3D object in here. Now you'll notice that it's actually quite distorted. The original image is tall and thin, and this is square. So now I'm going to show how to fix that. But at this point, it's possible to save the project into VRChat, save the project in Unity, upload it into VRChat, and then go in and view the world in the headset to verify that the image is 3D. In the Unity window and in PC, it will not look 3D. You have to view it in a headset. So the image that's in the scene now is on a square cube, and the actual image is tall and thin, or it could be short and wide, and so we want to correct the size of the quad so that the image looks good, so it looks correct. And to do that, first of all, we'll assume that the image height is 1 unit high. So we're going to change the width of the quad so that it will correctly display 1/2 of the image. And we do that by calculating the ratio of 1/2 the width to the height of the image. And so I'm going to, this is the formula, the ratio equals 1/2 the width divided by the height. And once we have that value, we can apply it to the X scale of the quad, and the image should look correct. All right, now I'm going to calculate that ratio, and I'm using an RPN calculator, which may look odd to some people, but you can use any calculator. And here's my image, and down here at the bottom it shows the dimensions, the width and the height. So I start off by keying in the width, 1,754, enter, and I'm going to divide that by 2. 2 divide by. This is the way an RPN calculator works. Next, I'm going to divide that by the height of the image. So I key in 1,568 and say divide by. And the resulting value is 0.559 something, and I usually round down to the second decimal. So in this case, in Unity, in the inspector, for that quad, I'm going to put in the value 0.55. And you noticed instantly that the ratio changes on the picture and in the scene, and now it looks much more normal, the way it's supposed to. Now the picture, the actual object that's in the scene may be too small or too large or at the wrong angle or the wrong position, so you want to move it, rotate it, and scale it to put it in the correct place at the correct size. So you might be inclined to grab hold of the image quad itself to do that, but that is not really the best way to do it. The best way is to grab hold of the container, not the quad, to make these changes. And I'm going to show you that. Okay, here's the object, the image object in the world. I can back up and show you. And it's 1 unit high. Each of these squares on the grid is 1 unit, and this is 1 unit high. So what I want to do is move this object around and change its angle. So you might be inclined to grab it by the quad object to move it, but it's much better to grab it by its container. And then if you take the container, you can move that around or rotate it or scale it. And this way, you notice that the aspect ratio does not change. That's because the aspect ratio is contained in the quad, and which you notice is still at 0, 0, 0. That's 0, 0, 0 inside the container, whereas the container itself now is at different positions, rotations, and scales.